All right, so today we're taking a look at week 2. We're mostly just going to be focusing on the intermediate scripting stuff, as well as make a mention of that building better state machines. But in here, there's some tutorials brushing back up on the different topics of intermediate scripting ideas and things like that. I do recommend you go through each one of those in addition to this lecture. We will be deviating from them, so they're not the same thing, and we'll be showing them in different ways of how to explain each different topic. But to get started, first thing that we want to talk about is inheritance. So that's creating child classes and things like that. And what I have here is just a brand new empty scene from Unity. And we'll go ahead and create some basic things to move around and show how they can be used in gameplay examples. First thing we'll need is an actual floor for our characters to move around in. I'll go for terrain. Why not? I'll make sure to modify the terrain. So let's go 50. I know the last one we used 100, but we don't need that big of an area. And we'll also move it so that it's centered in the world. Next up, let's go ahead and create a character that can move around. And I'm going to rename this, so we'll just call this floor. Terrain was probably fine, but just want to make sure that I remember to rename the items as I'm creating them. Next up, we need something to move around on this floor. We'll go ahead and create just a simple capsule to represent a character. And before I forget, we'll go ahead and call this player. And we want to select it and move it up out of the ground, which will be just 1 in the Y. Next, we want our character to be able to move around. And there's several different ways we can do that. You guys have probably been shown mostly adding a rigid body to it and stuff like that. We're going to look at a different component today called character controller. Character controller is actually a type of rigid body that adds some extra things that we may want to define its type of movement. Like you can specify how steep of a slope it can go up of, and different things like stepping over different other collisions and things like that. Radius and height by default will match our current capsule. On that note, the radius and height, there actually is a capsule collider built into the character controller. So I want to do this, and I'm going to just remove the capsule collider that got created when we first added the capsule. So once we do that, we do see that it still has that capsule definition around it with those green lines indicating its collision volume. Next, we need a script to control this character. So we'll just go ahead and add a component, new script, and we'll call this player controller. Let that load up and open the script. All right. So in here, there's a couple of things we'll need to do to get our character moving around. Very first thing, we're going to want to access that character controller. And in order to do that, rather than typing get component character controller everywhere I want to use it, we can just store that into a variable. So type of variable will be a character controller. We'll make it shorter by using CC as the name of the variable for it. And we'll initialize it to null at first. And in our start, we can go ahead and set that variable to the character controller attached to this game object. We'll do a get component and look for a character controller component. Then in update, we can go ahead and tell it to use this character controller. First thing, we want to make sure not to try and tell it to move before we check any inputs or anything like that. In order to do our movement for our input, we'll be getting the axes values from the input system, but we need a variable to store how we're moving. So I'll create a vector3 to indicate our move vector. We'll initialize that to just an empty vector or 0 vector. We're going to initialize that each frame. So each frame, we're going to check our inputs and update what direction we're moving and things like that. Now, you notice I did actually create this move vector, this vector3 move, inside our update. Now, I could have created it outside next to this one and been able to use it in update, but since we're only using our move vector inside our update for now, we can keep it as what is referred to as a local variable. Our start function, or any other functions we may write inside this class, won't necessarily be able to use that unless I moved it out to the class level. So with our move vector, we're going to be setting it to a couple of different directions. I want to be able to move forward, back, and left and right. So we'll say move equals our input get axis. And not sure if you're aware, but there's a couple of axes set up for you. There's what is called the vertical axis, and that's on W and S or up and down arrow keys. That'll represent our forward and backward movement. So we'll get that vertical axis, and we see that's just going to give us a float. If we're pressing W, it's going to be +1. If we're pressing S, it's going to be -1. We also need to say what direction. Well, since this is our forward direction, we'll use that to scale our current forward facing. So our transform.forward. So even if we rotate our character, whenever we press W, we're still going in the forward direction. Next up, I don't want to just say move equals and then do our get the horizontal axis. I want to add on, so not overwriting our vertical axis stuff. So we'll do a plus equals instead for this one. And we'll get that horizontal axis for our side-to-side movement. And horizontal is A and D, or left and right arrows. We can then multiply in our right vector this time. Lastly, all we've done so far is just create the vector3 move, but we haven't really told our character controller to do anything with it. So we can say CC, and there's a couple of different move options. If I just type move, you see there is this move function that takes absolute movement deltas. So that means I have to figure out exactly how far I want it to move. Whereas if we take a look at our simple move function, we can just specify the speed of which axis it's going to move on, and that's our vector3. We want it to move in the direction of vector3, and we can just specify it as a speed. So we'll pass in move, and that would be fine, but right now it's just going to move at most 1 unit per second, because the forward and right vector are just a unit vector. So we would have to scale this by some sort of speed. So just to keep things nice and easy to work with, I'm going to create a serialized field so that we can change it in the editor of a float, and we'll call this move speed. And we'll just say we want it to move 5.0 units per second by default. So anytime we're sending in simple move, we can just scale that move vector up by our move speed. We'll save that, and we can go over to Unity and test this out. Press play. If I press WS, so we got WASD movement, but our camera is not following around our character. Easiest way to get our camera actually following around our character, just attach it as a child to our player. Now we'll move the camera up, and we'll also move it forward a bit so we get a little bit over the shoulder as well, kind of like a third-person camera view, so that as we're playing, we'll be able to keep that camera in position and have a good view of the actual scene in front of us. So we've got our character, got some basic movement in there. We need something for our character to interact with. One of the best ways that I tend to show the inheritance is using something called for pickups and stuff. What we can do is go ahead and create a pickup script. We'll create a few different scripts, but this very first one will just be a base pickup script, and we'll call it pickup base. Make sure to open that up. And what I want this script to do is just handle the collision detection. So we'll get rid of all that stuff, and we'll say on enter, or on trigger enter. And yeah, we'll just deal with the enters. We don't need to worry about the exits. And what we can do is have that call a specific function that we write called, well, whatever function we want, but we want this function to have no return, so we'll avoid the return type. And we'll call it activate pickup. Now, what we are going to take in here, well, we'd want to know a little bit information. So our on trigger enter, we see is past the other thing that it's colliding with. We can go ahead and pass the game object from that other collider into this pickup. So we'll say we're going to pass in a game object, and we'll just call it other, keep it simple. And we need to make sure anytime something enters the trigger, we'll go ahead and activate the pickup. And since this is base pickup, the majority of pickups you typically want to destroy themselves after, we'll go ahead and add that in there as well. So we'll say, make a call to our active pickup function, pass in the other game object, and our activate pickup, well, when you activate a base pickup, we're just going to have it destroy itself. And we don't necessarily want it to destroy the script, which is this. We want it to destroy the script, the actual object that this component is attached to. So that'd be our game object, lowercase g. All right. So we can save that. And let that compile. Now, if we want to create like a specific pickup, we could actually inherit from this base pickup script. So let's go ahead and do that. Let's create a new script. And we'll call this one pickup. Let's say you're going to pick up, one of them is going to be called puppies. And we'll open that script up. By default, any script you create will inherit by mono behavior from Unity. But we don't want to just inherit from mono behavior here. We want to inherit from our pickup base. So we can just change that. And now we have everything that our base pickup would run. For example, if we clear this out, we have nothing in this script. And in here, if we actually create an object for our puppies pickup, we'll use just a simple sphere. And we'll shove it off to the right of our character. And we got to remember to actually attach our pick up puppies to that object. We can do that through the scene, drag it on the hierarchy, or even if that object's selected, we can drag it into the details here. We've got our puppies pickup attached. We'll rename this before we forget. Puppies. And right now, even though that script is empty, we are telling it to inherit from our pickup base. So if we play test this, oh, totally forgot to make puppies a trigger. So fix that real quick. If we play and we run into this pickup, we see it did destroy itself. So even though our pickup puppies is empty, because we're saying inherit everything from pickup base, it's going to do that, all the code that pickup base has. And chat, there we go. Oh yeah, well the puppies went away. It's a sad time for everyone.
Quick question.
Yeah.
In the pickup puppies script, you can add like special functions or anything, like add like this to health or add to ammo, basically.
Exactly, and we're going to do that in a moment. I just wanted to show like this script looks empty, even though it's not. It's running everything that pickup base is.
All right,
Now,
cool.
if we wanted to change it so that the puppies don't just get destroyed and do something else, maybe like a print string or something, we have the option inside any child classes to override what our parents are doing. Now, if we try this right now, we see we have the option to override equals, override get hash, and override to string. Those aren't too helpful. I specifically want to override what happens when we activate the pickup. In order to be able to override in a child class, that parent class has to add a keyword to this. We can say this is virtual. And it's going to complain because virtual members cannot be private. So because this was by default, everything comes in as private inside a class, only this class would be able to reference it. We would have to use a different protection level. We could use public, but then that gives anything access to modify this script. There's another one called protected, which means only our children can play with this, not everything else in the world. So it's just a higher level, but not entirely private. So we'll save that. And now if we pop back over here and look at what we can override, we can override that activate pickup now. So our puppies, if we let that autofill, we do see it came with base activate pickup. So that's just adding a call to the parent class, letting us know if you still want that functionality, you can keep that in. If we don't want that functionality, we could comment it out. But it gives us that nice ability to add any additional functionality we want and still keep that base functionality. So for this, on our pickup puppies, we'll have it add a debug log, not debut, debug log. And we'll just say playing with puppies, life is good. We'll save that. And we can try this out. I'll make sure my console is showing in case we don't see it way at the bottom. And we hit it. We get playing with puppies, life is good, and it still went away because that base pickup functionality was left in. So that's fantastic because our pickup puppies now can just focus on what our pickup puppies needs to. Our pickup base is for anything. It's got the actual collision message in it, as well as some basic functionality from all pickups can share. This comes in really handy if we end up having other things in here. For example, if we were to, let's say, set up on our player controller when we press space, it's going to shoot. Going to need a couple of things for that. We need an object. We'll just say sphere. Zero that all out. We'll add a simple component to it. And we'll just call this projectile. And hope I spelled that right. Yep. And we'll just say it's going to move forward whatever direction it is. So transform dot position plus equals transform dot forward times, let's say it's going to move at 5 units per second. And we also want to multiply it in time, since update runs per frame, not necessarily based off time. So we can ask time for delta time, the time since the last frame. Compile, save. And just taking a look at this, if we have it, for example, right in our character, and we press play, should see it shoot out. Well, the collisions pushed it out. Okay. And we see it moving along. If we actually try and move that over so it'll collide with our puppies and play test this, we see it didn't actually interact. So let's pretend for a moment that I added a rigid body on here, which I forgot to, because overlap messages do not actually get generated unless there's a specific overlap. I believe I showed that in last lecture of the enemies not reacting to when they hit a nav point. We'll go ahead and add a rigid body here. We don't necessarily want gravity on this, and we will say is kinematic since I want my script controlling it directly, not any physics reactions. We'll play again, and we see our bullet just destroyed our puppies. That's not too great. We don't necessarily even want our pickups to react to puppies whatsoever. Or we don't want our pickups to react with our bullets whatsoever. So we can go into our pickup, our base pickup, so that all our pickups will get this new functionality added on there, and say, before we immediately just say activate this pickup, we'd want to check what type of object we're colliding with. Not an iterator, an if check. And we'll be checking if that other has a certain component. And we'll be looking for the player controller component. So this way, it'll ignore anything else any other game objects that don't have a player controller component. And we'll play this, and we see it just goes straight through without having the puppies try to activate their love on the projectile. This same functionality now applies to any other thing that we've derived or created another child class of. So instead of puppies, as an example, let's go ahead and add another pickup. This will be, well, let's go for a cube. And we'll rename this mosquitoes. And we'll actually put that just past the puppies there. Before I forget, let's make sure it is a trigger. And we'll add a new pickup script to this one. We'll call this pickup mosquitoes. All right, so in here, we could add some extra stuff in start or update. For example, if we wanted this to rotate or something, we could add that all here. In fact, let's do that just for fun. But big thing we want to do is make sure to say, instead of just using the basic mono behavior, we want this to be a pickup. And we also want to override what happens when we hit it. For this one, I'm going to say when we hit it, we don't want this one to go away. This is a swarm of mosquitoes that even when you walk through it, the mosquitoes don't just go away. We'll just add a debug log. And we'll say mosquitoes are attacking you. And as I mentioned, we can add anything we want inside our update. Let's go ahead and add a rotate. Let's see. I think it's transformed, rotate. Yep, we'll rotate around. Sorry, I want to look at the overloads. Overloads, we can specify an axis and angle. Axis we want to rotate around is going to be our up direction. And the angle that we want to rotate, we'll say it's going to rotate 15 degrees every second. So we'll multiply in our time. Delta time. Just to give this one a bit of a different look. Save that. And we press play. And we see our projectile no longer interacts with either of those, but if we go through it and we hit that pickup, puppies, we're playing puppies, life is good, and then you run into a swarm of mosquitoes and mosquitoes are attacking you. And because we are overriding and we got rid of that base dot pickup activate, it no longer destroys itself after we're done. We are actually overriding all of that base functionality and specifying our own stuff that happens. So all it's doing is saying is attacking you. So any questions about inheritance with the override, being able to interact with a parent, having that actually inherit from something different and interact with the parent, having all this code run, even though our child classes can focus on just what they need to do?
No, I think it was a lot of aha moments this week. So
Okay.
a lot of things are like clicking for me, like making
Cool.
more sense. And so just in that pick up mosquitoes, after you take away the base away from it, since
Yeah.
it's not, would you add a destroy object if you want to destroy?
Yeah, you
And
could add whatever code you want here for this specific pickup. The reason why I do the pickups is because most oftentimes they'll have it destroy just after the pickup. And since that gets added, the parent gets called for you. You can add that base pickup back in if you want it there still.
or just if like how you had it, if you're like in a section part of the game and you wanted to get attacked by certain things but not get destroyed, that's how you have it.
Yeah,
Okay.
you could have some immediately just destroy, or like if it's supposed to be an area of effect or like area hazard that doesn't just disappear after one use, then you
Yeah.
would really destroy it.
Okay.
All right, so I'll comment that back out. So that's pretty much inheritance. And next up is polymorphism. So polymorphism goes hand in hand with inheritance. It basically means that these objects are treated like more than just one type of object. So for example, if our, even though this pickup mosquitoes is pickup mosquitoes, it is also a pickup base. So if I looked for every object in our game that is a pickup base, and let's go over to our player controller and have it add an array of objects for pickups. If we have our pickup base type there, and we look for, we'll just call these pickups. We'll initialize it to null. And then once the game actually starts, we'll go ahead and say pickups equals find objects of type. So when you are using like find object of type or find objects of type, be cautious about which one you're using. The one with the S will return all of the active objects of that type, whereas find object will just give you the very first instance it finds with that. So if we do find objects, and the type of objects we're looking for are pickup base, and we save this, and I'm curious if it'll show up. So we'll just leave that as is, and I want to check this out if it'll show up in the inspector switch to debug mode. Got to play. Right now we don't have anything serialized, we can't see anything, we weren't printing anything. But if we actually switch this to debug, it will show you private variables, but because we didn't use it anywhere, it's not going to show me that. Dang it. I was worried about that. Okay, so let's say we wanted to, and after we found all those pickups, we can loop through each one and print their name. So you guys have seen simple for loops before where you do like an int I is less than, all that. There is another type of for loop called a for each loop. And this is specifically useful for containers and things like that. For example, we have an array. We can have for each pickup base. And we got to give this thing a name. We'll call this cur, since we're going to be looping through this in the actual collection we're looking for, which is our pickups. We can then use this variable cur just like it is a base pickup. Cur, and let's actually just do a log of their names. Debug log, pickup base. Oh, not pickup base, dang it. Let's add some nice things to this string as well. Found a pickup with name, and then we can print the actual current pickup's name. All right, and let's give this a run. Play through it, and it found mosquitoes and puppies. So even though our nothing in here actually has that script, and let me swap that out of debug. Nothing has a, why did I select the projectile? Come on. Nothing has a base pickup script attached to it. Because these are children, they are still treated as the parent object type as well. So with that, even though we only have a reference to pickup base here, and it doesn't know about pickup mosquito or anything like that, if we tell it to run a function, such as our from our current, which is a base pickup. We have our activate, pickup activate, which I made private or protected, so we can't access that from here. Let's swap that real quick and let our character have access as well. We got to update our child classes for the right protection level as well. Public. Then back over in our character controller, when we try and use that, we can call activate pickup from it. And the game object we'd want to activate it on, well, we'll be passing, since we're in our character controller script, we'll just be passing our game object. Save all that. Play this, and we see it activated both those pickups. We found the pickup with mosquitoes, told the mosquitoes to attack us. Found the pickup with the name of puppies, it told the actual puppies to attack or to play with us. So even though we, in our player controller, we're telling it cur activate pickup, because that's pickup base. If we just look in pickup base for what it's doing, its activate was just destroying. But because they're actually those child objects, the code itself knows they are a child object, and that functionality was overwritten in the child. So we're going to use that functionality instead, not just that base pickup. This comes in real handy, for example, if you have different items or something and you just say item activate or something like that, and you only have a reference to that base item. Each individual item could have its own functionality for what it does, or whether it's going to be adding health, whether it's going to be like a mana potion or poison or something like that. Each individual item, even though you only have a list of the base item, you don't need to worry about branching. You can just call activate or do your work straight from that base reference that you have, without having to do a bunch of branches figuring out, is this the certain item? Then we need to cast it to that. Then we need to call its pickup and stuff like that. So that's what, part of the reason why they're called polymorphic, because even though it's just that pickup base that it's being treated as, it still reacts as another type. So keep that in mind. If we actually are in here, and for example, we're looking for specifically our mosquitoes. If we tried to take our cur and cast this to our mosquito pickup, or pickup mosquitoes. And oh, can't type today. So this is what is called a C-style cast. We're actually saying, take this base type and try and cast it to this other type. We can store that into a reference. So we'll create a variable of pickup mosquitoes. We'll just call it M. And we'll set that equal to it. So this is trying to cast to a child class and store it in this variable. We can then check if M is not equal to null. We can log out found mosquitoes. And we could do the same thing for puppies, but just for this demonstration, I'll keep it simple, just looking for the mosquitoes. If we play, we see invalid cast exception. Specified cast is not valid. So it tried to cast our pickup base to the mosquitoes. If we look at this again, it didn't have a problem when we were passing the mosquitoes. So only when we tried to cast that puppies to mosquitoes, it was failing. So keep that in mind, getting the specific types by using like a cast like that versus dynamic cast or get component and things. You're gonna have a bad time if you try and just get that specific type. So we can prevent that by just having it be a child class and just having that simple interface called activate pickup, or even if you have like a deactivate added onto the base class, you can go ahead and run with all those. All right. So member hiding is a way of just hiding certain things you're inheriting. If you're creating a new variable named the same thing, it can actually hide your parent's variable from the child and stuff like that. You don't need to worry about that too much. That's more of an advanced topic that isn't really necessary for designers. Overriding, that goes hand in hand with inheritance and polymorphism, how all those work. Interfaces. So we have not talked about interfaces yet for this class. Interfaces, you may remember them from PGF2. We were creating interfaces for things to talk back and forth to each other in Unreal. And one thing I want to mention about inheritance that I forgot to mention already, if we go to our pickup puppies and wanted to inherit from not just pickup base, but if we wanted to inherit from another class as well, and we try and add one of those on using like a comma, we can't actually inherit from multiple classes. So let's say we do pickup base and also projectile. Not sure why you would want both those functionalities on there, but we can't actually inherit from multiple classes. Here's where interfaces come in. We can actually inherit from multiple interfaces. So they come in really handy when you have some basic functionality you want on several different items. For example, on our, let's go ahead and create an interface first before we get too far into it. And we are stopped playing. Let's go ahead and create just a new script for this interface. We'll call this I, and we'll say I underscore damageable. So, I damageable. We don't want any of the stuff that it gives us. We don't want to inherit from mono behavior. We don't even want it to be a class. We want this to be an interface. So we change that, and we see it's got a different highlight for interfaces versus classes. This one's like a light green almost for the color settings I have. What you can define in an interface is different functions. So let's say we have a function named take damage. It's going to take in nothing, or going to return nothing, and it is going to be called take damage. It's going to take in one parameter, just a simple float, to represent how much damage it took. And we'll just call that input damage. Now, if I try and define this function here, we see target runtime doesn't support default interface implementation. What does that mean? Well, that means the function itself, when you're defining an interface, cannot have any body. So we can't define what this function does until we are actually in a class that uses it. So let's say I did want our pickup, all our pickups to be damageable. Or let's actually just do mosquitoes. Let's make our projectiles into mosquito repellent. We'll say that it inherits from pickup base, but also inherits from the interface I damageable. Now we notice as soon as we add that red line, the only reason why we've got a red line is because this one doesn't implement the actual function. Because the interface itself doesn't have a body, we need to say what this function does somewhere. So we'd have to do that in any class that actually adds this as an interface. To implement that function, we'll go ahead and just say, and take info won't pop up. Darn, I was hoping it would get that from there. We'll go ahead and create a function. We'll do void, we can say from iDamageable, take damage. Let's just use simple log for taking damage. Log mosquitoes took add on the damage amount and add on some nice formatting for damage, our actual string that will get printed. All right. If we play this, we'll see we have our projectile just going straight through it. Nothing was actually applying damage or anything yet. But this allows our projectile script to get a little bit simpler. Rather than checking, is it specifically when it's hitting something, let's go ahead and add that on trigger enter. When it collides with something, we'll go ahead and check if other has the component, and we'll be looking for an iPickable or iDamageable component. If it does, and I'm going to want to wrap that in an if statement, we'll put an if statement below and just catch a reference. So this is actually looking for that component. We'll go ahead and catch a reference to that component, damageable. And we'll call this D for short. If D is not equal to null, we'll go ahead and apply that damage to it, or call the function take damage. How much we'll do, we'll say each bullet's going to do 5 damage. Why not? Just some arbitrary number. And we'll just save that. And we can test this out. If we play, we see mosquitoes took 5 damage. Now, if we also wanted our player, and I'm going to actually move him in the path of that projectile rather than changing how our projectiles work. If we want our player to also handle damage, we can go ahead and say, not only is it a mono behavior, but it also implements the interface iDamageable. We can then add that down here. And we can say whatever we want for when our player takes damage. Player took damage. Add on the damage here. And without having to modify our projectile at all, we now see, well, dang it, it actually collided with our player. We'll swap our projectile over, and I didn't rename it. I was trying to be good about that. Projectile. We'll make sure that it is set as a trigger. So we see our player took 5 damage, and then our mosquitoes took 5 damage. So we've just created different reactions on 2 completely separate types by just handling it through that interface. Our projectile doesn't know about either one of them. They just know about this interface and how to talk to it. So that comes in really handy when you have things like damageable, destructible. Those are the best things coming to my head. And you could even create one for how our pickups work if you want to create pick-upable or one-time use or something. You can just tack that on to whatever classes you want to respond to it. And then all your other objects that were looking for something that, such as damageable, can just do their things as needed. One big thing about interfaces. So we see we can add this function here. If we try and add, let's say, an integer, int, for damage, how much damage it has, or like how much health it has, interfaces cannot contain fields. So that means we cannot contain any variables or things like that. So if you ever wondered about that, fields are referring to class variables. Methods are referring to class functions. So the only thing it can have in here is a function declaration. We can't even define what that function does or say what it's going to do. We can just have the basics of what return type is it going to have, what's the name of the function, and what kind of parameters will be passed in. So, any questions about the interfaces, what we talked about so far for that one?
I'm good.
Good on that? All right.
Yes.
Moving on to our next element, extension methods are another way of adding additional functionality on. Once again, that's more of an optional thing for designers. You don't need to worry about that too much for design scripting and stuff. Namespaces. So we've used them before, and we've taken a look a little bit at them. But let's actually take a look at creating our own namespace. So right now, we've seen things such as the using statements up here to get access to specific interfaces or specific types and things like that we need. Let's change this so that all our pickups are wrapped up into their own namespace. So we'll start by wrapping up our base pickup, and we'll just say namespace and then give it a name. We'll call it pickups. And we can wrap all of that using the curly braces to define what's inside it, just like that. we're going to get a bunch of errors because now our pickup base is inside there. Let's go ahead and wrap up our mosquitoes in this same namespace pickups. And we also have our puppies. We can wrap those in our namespace as well. The last thing we're going to get is a complaint about our player controller, because that's where it was trying to store all our pickups and use them and call activate right at the beginning with our for loops. So our player controller, we wouldn't want to put inside our namespace for pickups, but we would want to use that namespace. So we could add our using directive of pickups. And now that we are using that namespace, we have access to those different types that we've created for the pickup base and have access to it. This comes in really handy to actually encapsulate the different systems that you have. For example, our HUD wouldn't really need to know about our pickups. Our projectiles don't necessarily need to know about our pickups. So it allows it to keep things a bit cleaner when you're looking for things and you have maybe 5 different functions, so 5 different base classes that all have the term activate on them, but you don't necessarily want the pickup activate or anything like that. We can wrap that in a namespace and just have that show up as needed. And let me just save and make sure to play to show that that is all still functioning as normal. So we just encapsulated all that code. Anytime I'm in here, if we look for pickup, we have access to all the pickups right through there. If we were in something that doesn't necessarily need to know about it, like our projectiles, if we try and bring up pickups here, we have access to the namespace pickups. But we don't have access to, like, I guess we could add pickup base. It will find it, but it actually added the using statement for me. So that's a new thing they've just recently started doing, where it'll automatically add the reference you're looking for. But we see without that using directive, we don't have access to any of the pickup stuff. So any questions about namespaces? They're a pretty straightforward concept. One thing I do want to point out is that we're actually saying this namespace has pickup base, and we're using it across different actual scripts and stuff, but all of these, the pickup puppies, the pickup base, and pickup mosquitoes all exist within that same, just the normal pickups namespace. So you can use them across different scripts and stuff.
Thank you.
Yeah, no problem.
I think, yeah, it was more clarification on everything that you've shown.
Cool. All right, so that's about it for today. Just going over those, then we have the test that is covering those different topics due tomorrow. Make sure you run through that. And then lastly, we have this that we'll just talk about briefly, since this is just a few different videos talking about more in depth on state machines, the different types of state machines, and how to use them. One that I do really want to point out is this game programming patterns, design patterns revisited. So this will link you to an actual entire book called game programming patterns. And it is not just a fantastic reference for what a state pattern is. It has a whole bunch of different chapters and contents for a whole bunch of different patterns that come in really handy when making games. I do recommend that you actually add this as a favorite or bookmark just for future reference, because it goes over a lot of really great common topics about different patterns that may not get covered in the normal classes. And then the others are just videos kind of explaining each different types of the state machines, exactly what they are. There are benefits to some, negatives to some, and it is a situational thing that you would want some functionality from, say, a Amelia Moore state machine versus a Harold state machine. And it'll all be determined by, once you understand those different state machines a bit more, why you would use one in a situation where you could have used another and stuff. And then on our next class, which will be Wednesday, we'll actually be talking about the state machine that we're going to be providing for this course, as well as taking a look at how to use that with a test following up on making sure that you understand how things are functioning in it. There is this post and reply for a feature analysis. This has you break down a specific game that you are currently playing or like in the past to actually kind of understand what types of states there are. There are no right or wrong answers for that. It will just be based off of trying to get your mind in a state mentality of what could be considered a state, and then reply to others, giving them feedback. On that note, I know there are only 2 students currently in the lecture section. I will be copying some others over from the other sections so that you do have a chance to reply to everyone. All right. Other than that, that's about it for today. Were there any last minute questions before I go ahead and head out of this session?
I'm good.
Alrighty.
Thank you.
Check the chat. Oh, Wyatt's good as well. Alrighty. Everyone take care, and talk to you on Wednesday.
See you Wednesday.